So Star Wars API is like, so let's punt and change this to, instead of Star Wars, people Star Wars.
I thought you didn't watch Cardinal College. This is just the game day.
Yeah, I know a few words. People in space. Hey, look at that. We don't even like, hey, people in space. And then rather than this, let's use this API. We're changing out our API here. And then let's take a look at return. So this is kind of gross, right? So I can read this here in the browser. If we go to Chrome JSON Viewer, there's a plugin called JSON Viewer that we can install. Oops, I want to be in Chrome. Let me do this in Chrome because I want to confuse you with. All right, so here's our this cruddy thing. It's kind of hard to read. Chrome JSON Viewer is a plugin we can add to our browser. Let's add to Chrome. Add the extension. So now that we have that extension, hopefully when we reload this page, right, we get something like way more beautiful. Because that extension is seeing that this is JSON and will format that result. So just Google search Chrome JSON Viewer and add that extension. And let me dump this.
JSON Viewer or JSON View?
It's Chrome JSON Viewer extension.
JSON Viewer. Okay.
Add that, and then this is the API we're going to use instead of the Star Wars API because that works way better. So here's our API. So we don't want to pass people as JSON results. What do we want to pass instead? People. And then here, right, people names should work, right? Because inside of here, the people array is this, and the dot name should still work. It's people for each person. Oh, and I can't reuse this people here. Is that what this is complaining about? What's it complaining about? Jennifer people has already been declared. On line 35. Let's get rid of this. We're not going to do the next button. There we go. All right, cool. People in space instead. Yay! Like, and this like still works, right? So instead, we're fetching this list, right? And then outputting this. So what if we wanted to have their spacecraft as well? Right, we could change this to an interpolated string. Say is currently on the ship, the craft, person.craft. Yeah, person is the. Okay. So now we should get, right, Oleg is currently on the craft ISS. And there's our people. That works way better. Right. Does this API have anything else that's on here that's cool? The location of the ISS right now. That's interesting, but not super interesting. Here's where it's going to fly over. And the people in space. Okay. Cool.
Have you been recording the whole time?
Yes, I recorded the first half, and I'm recording now. All right. So what else do we want to show about this? So this works way better. At least this will be.
Yeah, here I'm stepping into the API.
No, so it's only the data that we back. We can modify what comes back and add more, right? But this API is just a, hey, here are the number of people in space. If this were the Twitter API, we were fetching back our own tweets. If I made another tweet, then that tweet would show up in my response.
Can you
Right.
see can you add like what they're tweeting about the ISS to this?
No. So those are two different APIs, right? This is just an API that gives me back a list of people who are in space. If I then needed to go to the Twitter API, I'd have to make a separate fetch request for that data as well, right? So if I wanted to get, you know, this person's latest tweet, I'd have to take this person's name inside of here and make another fetch request to the Twitter API saying, give me Oleg's tweets. And then I'd have to do something else to add those tweets below here. Right. So each API we access, right, we access for a specific reason. Right. We Google search the people in space API. Right. We started out with the Star Wars API that totally gave us a hard time. And we switched to this people in space one. Right. This the only thing that this API gives us back. Right. If we needed to then go join that with another API to go get us something more, right? Maybe we do a Google search API and get back the first result for Oleg Artemiev, right? We'd have to make another fetch, right? We could say, you know, fetch google.com search for, right, person.name. I'd have to do another API fetch to go get that information. And I have to then repeat this entire, right, then, return, response JSON, then, response, right, blah, blah, blah. I'm doing that inside of add people to page because I want to do this once for every person. If your request is, hey Gavin, how do I go do a Google search for each of these people? I have to do that during the for each. The only thing my main has is the stuff to go get the people and every time call add people to page for them. For each person, I'm going to make an LI and then I'm going to go do a Google search for them. Right? So I will do as many Google searches as the first API responded. So if your API has to go use an API, which has to go use an API, you're going to be looping and nesting those API searches. But we're not going to mess with that. It's hard enough just to get like this working, right? What's going on? Oh, this has a close tick there. Right. So we're starting to combine a bunch of different things. Right. You can kind of see we're layering. Right. We started with query selectors and having click handlers. Right. Now we have, oh, and then we talked about looping, right? So we have our arrays and our for eaches. We have objects. This person is an object. Right, we console.log this person. Right, here's each of those people, right, these objects. Those come from iterating an array of objects. And then being able to build dynamic DOM and inject that into the page. Right. This is, with one more thing that we'll talk about tomorrow, all of the bits that we need to have some understanding of, or at least references to, so we can bring them all together and start talking about building this in terms of a framework. Right. So there's a lot of rote code here that will kind of go away when we bring a framework in that will handle some of the drudgery part of this. Right? If we wanted to make Oleg this let's make that a link. Right? If we were to make that a link, here's what we'd have to do. Right? Rather than make text content, we'd have to say something like let person name link equal to a document create element A. Right? Let's make an href tag, a link. So the person name link, let's make the href equal to a Google search for them. And we do that by specifying a Q, and this is the person.name. All right, so we're just making a link here. Right? Now we can't do this. Now what we have to do is delete this, and then we have to say person li append child person name link. Oh, I did it again. I did a lowercase li. And then let's do this before we append the link. Is it any href? Did we get the href in there? Let's see. What I want this to be is this guy here to be a link. Oh, so let's do it this way. And then let's say the person name link text content is currently on. There we go. Let's just make the whole thing a link, right? So look how much work it takes to like build up, right, what would be simple in just writing out HTML, right? I have to make all these variables, and I've got to set all the attributes of them. It's this kind of thing here that once we make the leap to a framework, some things will get more complex because we've got to pick up the details of the framework, but building these dynamic responses will get easier. Okay. So the thing out of this today, remember, is fetches the API that allows us to access a URL and eventually get back some JSON data. From that JSON data, whatever its structure is, that is just going to give us back an object, and then we can pull information out of that object to do things with it. Right. Here we pulled back a list of astronauts that are in space. We were trying to fetch some Star Wars stuff, but that wasn't cooperating with us today. Right. The people attribute of this object is an array. We know that to work through arrays we use for each, and we end up getting back a whole bunch of these objects, and then we can create an element and append that child to the UL to get a dynamic user interface. If we look at, let's make this a super slow connection by going into the network and tweaking, right? We can see here when the page loads, hopefully what we get is people in space, and then, right, so that is the page rendering, then the API firing, and I on purpose slowed it down, and you can see that that data doesn't show up right away. But if the data is pretty fast, right, to us it looks like that data is right there in the page. Right? So a lot of the sites that you go to, what you don't realize is a majority of that page is fetched in the background and put into the page dynamically. It just happens so quickly, or it's cached so well, that you don't tend to notice that the page is doing that. Cool. Let's take a look at what your homework is going to be for tonight. So your homework for tonight is going to be using an API. It's cloudy with chance of syntax error. Use a weather API. And you're going to create a website that allows you to search for a location and get the weather for that place. So we're going to work on practicing an API. And we'd like you to use the openweathermap.org website for getting the weather. In Explorer mode, you're going to create a simple HTML page as a text box and a search button. When you type something into that search box and click the button, use the Open Weather Map API to get the current weather for that location and display that weather by adding elements to the DOM. So the elements that you are going to show them the weather don't exist when the page loads. You're going to add them dynamically to the DOM, right? And allow the user to either search by zip or city name. For adventure mode, go research the HTML5 geolocation API that will allow you to search for the current user's location when they load the page. Have you ever been to one of those pages that says, we would like to know where you are? That's the HTML5 geolocation API, right? And you can add that. And then store the user's last search and pull it and search for the page when it loads, right? So when the page loads, it should remember where that user last searched and just automatically search for that, right? Then see if you can remove the need for the search button and search when the user stops typing. So they start typing T-A-M-P-A, and they pause for a second, you search when they pause their typing and show them the results for Tampa. And then for epic mode, add a type ahead using Google's Places API. So there's another API for Google Places where you can start typing T-A-M and have it guess that you're typing Tampa. Or, and I think this one will be more appropriate for you all, go back to your blackjack and use that deck of cards API to replace your internal array of API of cards and anything else that you have there, like the dealing of a card. That API has all of those capabilities in it. See if you can then use an API rather than have a local deck of cards and dealing. So there's one last thing we've got to talk about if you're going to approach the adventure mode, and that is the idea of local storage. So one of the other APIs that your browser has, in addition to fetch, is called local storage. Right? So if you've ever been to a page, say like DevDocs, right? When I said DevDocs, you can have that work offline. So how does that work, right? How does it store something offline and still look like a web page? Well, your browser has built into it a certain amount of data that it can store based on the page that it's on, regardless of whether or not it's online. And there's really two. There's local storage and a local database. We're gonna work with local storage. So local storage is a variable that you get by default. Let's think about how you would use this here. Let's say we put on the page an input. Let's call it search.
You're doing that with the backslash.
It's a self-closing tag. You can do it this way too. The slash is optional because you just don't write this though, right? So input tags are self-closing. They don't need a closing pair. So I tend to write them this way to remind myself that that's a self-closing tag.
I do put search and it has no tag.
It's just text. You can just have just text inside of a body. It doesn't have to be inside of a tag. So this is just text that's free-form text inside of the body before the search. So what I'd like to be able to do is I would like to remember that if someone types search, they type hello, and they click go. The next time they load this page, I want that word hello to come back. Right? I want it to remember the search. So I want something to happen when the button is clicked. What technique do we use for? Yeah, we got to add that listener. So let's let the button be document query selector for the search button. And let's add an event listener for click. And then we're going to call a function. The function takes an event and it does something. Let's use our tracer bullet here, right? Let's say clicked. Look in the console. So when we click on go, hey, there's our clicked message, right? Standard stuff. So now, let's go find the search input by doing document query selector for dot search. Right? That's where the input is. And let's console log the search inputs value. So type howdy here and click go. Hey, look, I got howdy. So now what I want to do is I want to store that value somewhere. So where I'm going to store it is in local storage. So local storage is a variable that we get from the browser. And it comes with an API where we can set something with a key and a value. So it takes two arguments. The name of the storage we want to set, the key, and the value. Oops. Sorry, set item. Right? So I just told my browser, for this domain, localhost 3000, please remember the value of key is going to be value. So if I ask for a local storage get item for key, what's it going to return? Value. So if I set the item name to Gavin, and I ask for name, what am I going to get back?
Yeah.
If I reload the page, and I ask for this, I still get back Gavin. Remember before we set variables like let name equals to Gavin? And I reload the page and I ask for name, and it's gone. Local storage is how I assign something a value that's remembered even after the user reloads the page, right? They could leave my website and come back a year later, and as long as they haven't cleared their browser history, that value will still be there. So if I set the item, sure. So if I set the item search text, and I set that to the search input value, let's put this in a variable. Let search input value equal to search input value. So that column variable. Right? I'm storing whatever is inside of this search input value. I'm getting the input. I am asking that input for its value. I'm going to console log it. I'm going to tell the browser to remember it in the key called search text. So if I type howdy, right, the console log howdy. But now if I ask for local storage get item for search text, what am I going to have? Howdy. Right? So that means that up here, let's move this search input up here. Now what I can say is search input, its value is equal to local storage .get search text. Oh, sorry, get item. Yes, like get item. Okay, look at that, I remembered. See how that howdy's there? New search. Go. Reload the page, now it stores new search. So now my browser is remembering things, right? So if you're asking like, hey, how does my blackjack game remember how many wins and losses there are? If you use local storage set item with maybe the key of wins and then the number of times that user has won, every time your page loads, you could ask local storage, hey, local storage, get item for wins. Oh, this person's won 42 times. That value will be different from me when browsing your Surge than it is when Justin browses your Surge, because it's stored in my browser. If I fire up Opera and ask local storage, nope, different browser. Firefox, different browser. If I clear my history, local storage gets purged, right? So it's not a permanent thing, right? You wouldn't use it to like, store important information. But for something like what was the last thing that they searched for on the page, that sure is helpful.
Does local storage still remember howdy at all?
Nope, that's gone. Because I replaced what was inside of search text. Right? I set the item to whatever was inside of this, the text here again. Right? And if I make it blank, right, then it's blank. Right? And now it's storing that. Right? If I even open up a new tab, it's there. Right? But if I open up a new if I go into incognito mode, right, it's not there, right? Because this is an incognito browser, it doesn't have access to my personal browser settings, right? So this is the idea of local storage, where you can store something. So if you're going to try some of the advanced modes from the homework, you'll need that. Right? Or if you want to go back to your blackjack game and add a wins and loss record, you can add that. If you remember the scoreboard one, we were adding them, subtracting from the scoreboard. What if you went back to that assignment and said, hey, every time I add or remove scores to this team, I will set an item to track what their score is, so if I happen to reload the page in the middle, I don't lose their scores. Right? You can take some of these techniques back to old assignments and give them a try. Right? But the primary example here is learning to use this API and the fetch API method, and how to specify a URL and then process the results that come back from it. I believe openweathermap.org is going to require you to sign up for an account in order to use their API. But if we look at OpenWeatherMap's site, you'll start to notice that sometimes there will be these API references. Right? So here's their API documentation. They want us to sign up for free. But if you look at the API documentation, inside of here will be the example URLs you use in order to get data. So you'll notice there are things like by zip code, by city name, by geographic location, latitude and longitude. Right? So if let's just take by city name, and you look at the example here, it's saying if you call api.openweathermap.org data 2.5 weather !Q equals, and inside of here, don't put this, but put a city name, you should get back some data. So let's click on this one for London. Hey, we do need to sign up for an account. Yeah, because they're using their app ID. So I will revise the homework to talk about how to sign up for an account and where to put the app ID. Or I will ask Mark if he in the past has just been using this generic app ID. Like this is the one, like this is like their app ID. I don't think we want to use that. I think you're all going to want your own. But look at what the data comes back. Right? We ask for whether Q equals London, and we get back the coordinates of London, and the object that has the weather in London, temperature, humidity, visibility, wind, cloudiness, and a whole bunch of other stuff. Right? So this is the data we would get back if instead of saying Q equals London, UK, if we said Tampa, right, we get back this. It's supposed to be a light drizzle today. Right. And the temperature is 280. Kelvin. Yeah. Does it still say London?
The bottom. Is it because there was a space between the equal sign and Tampa?
You know what? This might be a fake. This might be some fake samples because it's samples.openweathermap. Let's try API. No, yeah, it's probably fake data because it's their sample stuff, right? And it's telling us that we need an API key. So yeah, it probably is not actively changing it to Tampa. So I will add to this documentation here how to sign up for a key and how to use that key. But what you're going to want to do is reference this API documentation page for the different things you need to do, right? So how to access by name, how to access it by geographic coordinates if you're going to do the HTML5 geolocation stuff, and then finally by zip code if you're going to offer the option for zip code. Yep, there's different API endpoints, different URLs, right? So this uses zip equals here, where up here, this uses Q equals, right? Where this is ID equals for the item. I'm going to click on that. And then finally, look at this one here. This is latitude and longitude. There's two different inputs to this one. So here, instead of 35, you'd have to put the user's latitude, and here, instead of long, you'd have to put the longitude.
Do they give you a location?
That's if you learn how to, you go Google search how to use the HTML5 geolocation. That's what pops up that this site wants to use your location. Do you say yes? That website is asking for the user's permission to use the geolocation API.
Well, that's pretty much what's the value of having your location? Like, I get it for the weather, but like, when a news article asks you for like,
They just want to know where you are for like marketing purposes. How many people from Florida are looking at my site versus people from somewhere else. And the geographic API is more accurate than like reverse locating the IP address. So they just want that mostly for a marketing perspective. Or maybe there's something that's like location specific, right? Maybe it's trying to show you like local news versus national news, right? But if you're at a site that, you know, is, I don't know, a recipe site, why do they want your location? I don't know. But if you do implement the HTML5 geo API, you'll get that saying this site wants to use, and you'll have to say allow, and then it will work. All right. So I will update the homework with, I'll put the homework out so you can start looking at it, and then I will update it with the instructions on how to sign up for an account, and then how to modify these URLs to have the key, because apparently this now needs a key. And I don't want you to have to like worry about how to deal with the key stuff. I'm just going to tell you how to do that. Your challenge is now to go practice with this API and see if you can pull out of this, right, the data you want to show, right? So figure out what you want to show in terms of temperatures or humidities, right? See if you can style it nicely, right? Make it look like a nice weather site. Get it to work first, right? Figure out what it's going to be, get it to work first, and then style it. And remember, what we want you to do is create those elements dynamically based off of the data you get back. Cool. Any questions on this that we haven't
Does it
covered?
specify what information? Just as the weather, so we're going to determine what portions of that API are going to give the weather. Like temperature, rain or no rain.
Yep. Current weather. Yeah. So you get to decide out of this what you want to use, right? So I challenge you to use a couple of different things, right? Maybe some temperature stuff, maybe this drizzle, right? Pull up a few different cities results and see if the results, what data comes back is different, right? Because maybe some places will have different data that comes back. I don't know if this has any of what the, let me see. All right, so here's the results, right, that come back at the bottom. Weather, Maine, temperature, Kelvin, right, pressure, wind. Right, so you can look down here at the bottom and see what all these things mean and figure out what elements you want to pull out to display on your weather page. Cool. So I'll put the homework out, and then I sit down and eat lunch, and while I'm eating lunch, I will go and look up how to create an Open Weather Map account, and I'll revise the homework again with the details on that.